Hey, thanks for tuning in to check this out, mathematics. And I encourage you to like this series of videos and subscribe to my channel and make some comments and watch more videos. And so, in this series of videos, we have been talking about formulas that generate Pythagorean triples and the underlying concepts involved. And so, these are the three Pythagorean triple generators that we had previously discussed. And in the episode prior to this one, we talked about this first triple generator. And in this video, we're going to talk about the middle one. And in the next video, we'll talk about this last one here. So this middle formula for generating Pythagorean triples is different than the one that we talked about in the previous videos. That's this one here, and that's because in the this Pythagorean triple generator formula here has a single basis value. That's just a one value, m, and m through these algebraic expressions will generate a Pythagorean triple. And this type of formula here only generates certain triples where the c value is one more than the b value. And you can see that here. This is the c value, and it's one more than the b value here. And so, for example, this is a Pythagorean triple that is generated by the m value of 4. That's 9, 40, 41. And in the previous videos, we talked about how the nature of these types of triples, where the c value, that's 41 in this case, is one more than the b value. And each of these types of Pythagorean triples have an odd number to begin with, and then the middle value, b, is a multiple of 4, and then the c value is odd. And so that's what we talked about in the previous video. And then we also looked at the expansion of the Pythagorean triple generating formula here. So we expanded each of these expressions to show that it is in fact a solution to the Pythagorean theorem, a squared plus b squared equals c squared. So I encourage you to go back and watch or rewatch that video to get caught up on these ideas. And so now we are going to look at this middle series of algebraic expressions that generate Pythagorean triples. This one here, 2mn for the a value, and m squared minus n squared for the b value, and m squared plus n squared for the c value. And this one is different from the previous formula that we examined. That's this one here, because this formula here requires just a single generator, m, where this formula requires two values to generate Pythagorean triples. And so let's establish that. So we are looking at m and n values as our basis. And these m and n values come from the natural numbers. That's the counting numbers, 1, 2, 3, and so on. And so if you pick any two m and n values, and that's where m is greater than n. That's very important there. And run it through this formula where you first do 2mn and to get the a or sometimes the b value, and then you run the m and the n through m squared minus n to get the a or sometimes the b value. I'm talking about A, B, and C always being in numerical order. And then you have m squared plus n squared to give you the C value. And so this Pythagorean generating formula here, Pythagorean triple generating formula here, does give us A, B, and C values where A squared is plus B squared equals C squared. We're going to have to put that square there. Okay. There we go. And again, m has to be greater than n because here we have a subtraction. So the m value has to be greater than the n value so that m squared minus n squared will always end up to be positive. Okay? All right. So what we want to talk about in this particular video is that this Pythagorean triple generating formula here doesn't just generate certain Pythagorean triples, as did this formula here. And so if you look at the illustration on the back here, we have 16 primitive Pythagorean triples. That means that these are the triples that for instance, with 5, 12, 13, this is a primitive Pythagorean triple, and then each one of these following are multiples of that Pythagorean triple. Okay, so this is an original Pythagorean triple or a primitive Pythagorean triple, and we have 16 of them. Okay, so over here we have the 3, 4, 5 Pythagorean triple, and then so that's the first one, and then 5, 12, 13 is the second Pythagorean, the primitive triple here, and then the third one is let's see, 5, 6, 7, 24, 25, and so on. And so I made a list of those 16 Pythagorean primitives here, and so we have each of the primitive Pythagorean triples here, and these are the m and n values that generate those Pythagorean triples according to our formula here. So what I'm showing you is that this formula here doesn't just generate certain Pythagorean triples. It in fact generates, I believe, all of them, or all of the primitives. Okay, so this formula here will generate all the primitives, Pythagorean triples that can be imagined, and then of course once you have all the primitives generated, then you just, the multiples come from those. Now this formula does generate other Pythagorean triples than just the primitives. And so, for instance, let's see, didn't really write this down, but let's see. Let's take, for instance, 3, 1. So if we have 3 and 1 as our m and n value, and then we have, so then we would say 2 times 3 times 1, and that would give us 6. And then for the 2mn, and then for the m squared minus n squared, we would have 3 squared minus 1 squared, and that would give us 9 minus 1, which would give us 8. And so then if we then do m squared plus n squared, okay, so the m minus n squared through our using m 3 and 1 as our basis here gives us 8. So now we can see that we're on the way to having 6, 8, 10 would be the Pythagorean triple that we're going to generate here. So 3 squared plus 1 squared is 9 plus 1 is 10. And so sometimes this formula that generates Pythagorean triples with certain values of m and n will generate a multiple of a primitive. Okay, so this is generating the 6, 8, 10 here, which is a multiple of the 3, 4, 5 above it there. And so this Pythagorean, this formula that generates Pythagorean triples will sometimes generate multiples of primitives, but not always. You're not gonna be able to create find all the multiples that way. But we will be able to generate all the primitives, and then the multiples just follow. So back to our list here, you can see here are our 16 primitives. The first 5 are listed here, where I'm putting the a value in order there, 3, 5, 7, 8, 9, and so on. And these are the m and n values that generate those primitives for the first 5. And then for 6, 7, 8, 9, and 10 primitives, these are the m and n values that generate those. So for instance, if you run the 7 and the 6 through our Pythagorean triple generator here, then you'll get the 13, 84, 85 Pythagorean triple, and that's this one here. And then so continuing, these are the other remaining Pythagorean primitive triples, and the m and n values that are used to generate those. And so the idea is that we have 16 primitives, and if we look at our illustration here, the 16 of them, this is the first one, 3, 4, 5. And then 5, 12, 13, and 7, 24, 25. And so you can see that when you have a primitive, these are all the multiples of those, and you have a primitive here, and those are all the multiples. And then you have a primitive here, 7, 24, 25, and the 3 multiples of those, where we're trying to keep every number under 100, that is, in this illustration here. And then, so that's the first and the second and the third and the fourth here, 8, 15, 17, and the multiples of that. And the fifth, 9, 40, 41, and multiple of that. And then the sixth, here we have, these are these values here in red are the ones that are with the triangular bookmarks here, are ones that if we do multiples of those will be out of range. So 11, 60, 61 for the sixth one, and then here's our seventh one, 12, 35, 37, and we have a multiple of that. And then 8 and 9 and 10, 16, 17, 18, 19. Here's 10, and then we have 11 and 12 and 13 and 14 and 15 and 16. Okay, and so this formula that generates Pythagorean triples this formula here that generates Pythagorean triples will is just generating any primitive and sometimes certain multiples, and so it generates all of the Pythagorean triples as far as I've researched, and so that's what I wanted to first establish, that this through these with this slide here and this let's switch hands here so it's in order. So with these 2 slides here and this one here, our Pythagorean triple formula that generates Pythagorean triples does in fact generate all 16 primitives that are on our board here, and then it should keep going as far as I've researched for any Pythagorean triple that can be imagined. Okay, so that's let's cut that off here, and then in the next video we're going to look at the expansion of this Pythagorean triple generator here to show that it is a solution for a squared plus b squared equals c squared. Okay, thanks for tuning in, and to check this out in mathematics, and be sure to like these videos and subscribe to the channel, and put down some comments and watch more videos and watch them again, and that way I can keep on making more content for you. Okay, thank you. Mr. Dahl signing off.